complementary angle trig relationships. We started it last lesson because we drew this table on the board. We typed into our calculators sine 20 and cos 70 and we found they gave us the same value. We did the same for some other angles. So that was what we found, but there was something special about the angles I'd chosen. In each case, that two angles add up to 90 degrees. So where we have two angles that add to 90 degrees, the sine of one angle equals the cosine of the other. So for example, sine 30 is exactly the same as cos 60 because 30 plus 60 is 90 degrees. And you'll remember from geometry before, if we have two angles that add to 90 degrees, they're known as complementary angles. So these are our complementary trig relationships. So where's this coming from? What's going on? Let's go back to a right angle triangle. So here, triangle ABC, it's got a right angle at B. We're going to call the other angle at C X, and we've got one angle remaining. Now we know the angle sum of a triangle is 180 degrees. We've already got a 90 degrees, so those two other angles have to add to 90. That's why our angle up at vertex A has been labelled 90 minus 80 degrees. We've worked that out. So they're complementary angles as marked. So let's label the sides. The side opposite vertex A is going to be a lowercase a. Similarly, the side opposite vertex B, lowercase b, and the side opposite vertex C is a lowercase c. So now we've labelled the sides, we can do some trig ratios on this triangle. So let's start out by looking at the angle at A, 90 minus x, and the sine of that angle. So sine is opposite over hypotenuse, we know that from SOHCAHTOA. So sine of 90 minus x is going to be A over B, opposite over hypotenuse. Now we look at the other angle, angle x, down at vertex C, I want to find the cosine of that. Cosine is adjacent over hypotenuse, but down at vertex C, our adjacent is A. Look at the angle and check that. The adjacent is A, hypotenuse B, so cos of x is going to be A over B. You'll see that they've both got the same answer, A over B. So that tells us the sine of 90 minus x has to equal the cosine of x. And in this triangle, we haven't got any numbers on our sides or our angles. So that means this holds true for any right angled triangle with any sides ABC and any angle x. Sine of 90 minus x is the cosine of x. Let's turn now to tan. Let's look at the tan of 90 minus x. So up at vertex A, we're trying to find the tan of that angle. It's going to be opposite over adjacent from SOHCAHTOA. So that's A over C. That's easy peasy. Done that 100 times. What about the other angle, x? Let's look at the cotangent, the cot of angle x. So cot is going to be A over O, adjacent over opposite. So the adjacent to angle x is A. So we've got A over C. You'll notice again those two expressions are the same. They're both A over C. So that tells us tan of 90 minus x has to equal cot x. So that's our first two sets of relationships derived. The final one, I could work through and do exactly the same for cosec and sec, but I'm not going to. You can do it yourself if you'd like. But you would find the sec of 90 minus x is going to give us cosec x. So if you'd like, you can get that down to see where those relationships have come from. But really, you just need to learn them. So on the next slide, let's summarize what we found. Sine of 90 minus x equals cos of x. But we could have done that exactly the same process starting the other way, and we would have found cos of 90 minus x equals sine x. So it does work both ways. Next thing we did was we looked at tan. Tan of 90 minus x equals cot x. Again, we could have done that the other way. Cot of 90 minus x is equal to tan of A. And finally, cosec and sec. Sec of 90 minus x is cosec of x. Cosec of 90 minus x is sec of x. Now you might think that's a lot to remember, I'll never remember that, but the names of those trig ratios tell us these are complementary angle relationships. Sine and cosine, you can see I've put that co in bold. That tells me that cosine is the complementary trig ratio to sine. Cot's proper name is cotangent. Tangent is the proper name of tan. So tangent and cotangent have this complementary trig relationship that tells us tan 90 minus x is cotangent of x. Cot of 90 minus x is tan of x. And you can see the same thing's going to happen here. The proper name of sec is actually secant. So secant and cosecant share this complementary angle relationship. Pause the video now and get this slide down in your books, including the diagram. Then move on. Let's use these relationships now in problems. What will we be asked? How can we be asked to use these relationships? Example 1 asks you to simplify a trig relationship. It could be a product multiplication, or here we've got a division. Cot of 35 degrees over tan of 55. So the reason we'll know to use complementary angles is we will recognise that those two angles add to 90 degrees. So make that statement. So you're showing that you know that they add to 90, and also state what that means. These two angles are complementary, because that's the definition of complementary angles. So how can we use that now? Well, because we're adding to 90, we're going to write one of our angles in terms of 90 degrees. So I'm just going to rewrite that statement, cot of 35 over cot of tan 55, cot of 35 over tan of 55. But where I've got that 35 on the top line, I'm going to substitute 90 minus 55, because I know that that's another expression for 35 degrees. And then I'm working towards some complementary angles. So all I've done there is substitute 35 for 90 minus 55. You can see that that's not actually used any trig, it's just substituting that number value. But now I'm going to use my complementary angle relationship, because my cot of 90 minus 55, well, that's really a cot of 90 minus x, and my x is 55. So what I can say is cot of 90 minus 55 is exactly the same as tan of 55. So that's what I'm going to substitute now. The only thing I've changed is cot of 90 minus 55. I've substituted in tan of 55. The reason I've done that, because cot of 90 minus x is tan x, and here my x is 55. So I've got tan 55 over tan 55. That's just a fraction with the same thing on the top and the bottom. It could have been 12 over 12. If we'd had 12 over 12, we'd know to cancel down to 1. And it's the same when we've got trig ratios. So tan 55 divided by tan 55 is equal to 1. So we've solved that problem now. We've simplified cot 35 over tan 55, and we found that could simplify down to 1. Copy that down in your book. Spend a minute to make sure you understand. Excuse me. And then pause the video, then move on to the next example once you're done. Example 2 is a slightly different approach. We need to solve an equation. So solving an equation means find x in this case. So what are we going to do here? Well, we recognise we've got a statement that the sec of one angle equals the cosec of another angle. And we know if the sec of one angle equals the cosec of another angle, those two angles must add to 90 degrees. So the two angles are complementary. That's what it means if sec and cosec are the same, the angles add to 90 degrees. So if those two angles add to 90 degrees because they're complementary, we can just take those two angles, add them up, and they must equal 90 degrees. So we've taken the first angle, x minus 10, we've added the second angle, 3x minus 20, and we're saying that equals 90 degrees. So now we've just got an algebraic statement. We can solve that quite simply. Let's collect our like terms. X plus 3x is going to give us 4x. Then we've got a minus 10 minus 20. That gives us a minus 30. And we haven't touched our right-hand side yet, so that's still equal to 90. We need to get the x on its own to find x. That's how we solve for x. So we need to take that 30 over to the other side. So we're going to add it. 4x is going to be equal to 90 plus 30, which is 120. Now to finally get x on its own, we're going to divide by 4. So we're going to have x equals 120 over 4. So x equals 30. We've solved that equation by using complementary angles, and our final value is x equals 30. Get that down in your exercise books. Make sure you understand, take the time, and you should be ready now to do the exercise in Maths in Focus. So good luck with that, and come to me with any problems.